Hello, my friends of Katari Labs. My name is Saul Montoya. Please welcome to this tutorial. In this tutorial, we are going to do an example of trench excavation, and this will be done with Modflow 6 and mf6Voronoi. Okay, as in any other tutorial, let's start with Anaconda prompt. Okay, you are going to receive on the description of this video. Okay, you are going to receive on the description of the video the zipped version of this of sorry about the zipped version. How much? How this? Which is the weight of this? It's 20 megs. Okay, okay. I mean without the model files. Okay, great. So now the zipped version is only 10, 10 meg. Okay, so you are going to receive this zipped version. So we are going to explore the spatial objects that we are going to work with. So here in documents on let's work with the chef files. So we have this is actually a channel system in Miami, okay, where we have here the a channel and well two channels, okay, that will be defined as general head boundary conditions. General head boundary condition. Okay, then we have the area of influence. Okay, this is the area of influence. There are some pumping wells, but this goes for the discretization, for the mesh generation, because actually we are not going to work with the, okay, we are not going to pump, but okay, we have inserted that. Okay, and then this is the trench. Okay, the trench is actually for, okay, is on four different stages. Okay, so we can do categorize over ID. Okay, so these are the four different stages. Okay, and the advancement of the trenches from in this direction. This is 1, 2, 3, 4. And this will be transient stress periods. Okay, we have one steady stress period, and then we have uh, four transient periods of 1 day where we simulate the excavation and also the closure, the excavation, and as well the, the excavation and the filling of the trench in the same day. Okay, okay, so that's it. So let's see, let's open. Okay, see the documents. And then we have a raster file that is a DEM file. It's a simple DEM file. It's almost it's flat. It's almost flat, but we had a DEM file, so that okay, so we apply that. Okay, CD documents, CD trench. Okay, and then here Jupyter Lab. Great. Hmm. Okay. Okay, the first thing here in scripts, we are going to do a new that is going to call P0. And the first thing that you have to do here is to install the latest version of mf6Voronoi. Please install you mf6Voronoi. Okay, great. So we are shift enter. So we start the latest version because actually, yeah, in any other version I have fixes to some code. Okay, so that is why. Okay, and the latest version is the 0.036 at the time of this tutorial. Okay, so great. So we are going to list the templates. Okay, list the templates. Okay, so these are the templates, but we are going to copy the generate Voronoi. This is for a trench. Okay, so we are going to copy as well the trench, the multi-layer transient, and the VDK generation. Okay, great. So here, let's generate the Voronoi mesh. So, okay, so import that. The here, this will be trench excavation. The maximum refinement is 1.5, and there is multiplier because the trench will have a thickness of just 1 meter. So that's why here we use a multiplier of 2.5. Okay, and the limit will be this. Okay, the trench excavation will have a thickness of 1. The pumping well will have a thickness of 2, and the compound GHB will have a thickness of 10. That's it. Great. So we generate the Voronoi. And okay, in my experience, I didn't have the problem of short sides. Okay, I didn't have that problem. Okay, I am working with 5,000 cells. Okay, if you have a problem with the short side, you can comment and run this cell and this cell. Okay, but I didn't have that. Okay, so now store this in output. Okay, and then let's have a look on the generated mesh. Okay, so here we have the wells, the trench, and as well the general head boundaries. Okay, now let's create the JSON dict. Okay, great. So now let's go to the multi-layer transient. Okay. Okay, now let's go to the multi-layer transient. Here we need, okay, we need one more line. Let's open the JSON file. Okay, and here let's open the raster file. And on the we are going to work with the top is almost 0 and the bottom is almost 20. So our layers will have 5 layers of 4 meters thick. Okay, so let's create, this will be on model files. The executable is here. So, and our model has 4 days, okay, of transient and 1 day of steady. 5 stress periods in total. Mhm. The solver is the same, this V is the same. Okay, there is a problem here. And the GW, okay, we have to run this, and run this. Okay, and this is the discretization. And now let's show a cross section. So if you look here, the first layer, actually the heads are not zero for the channel, are a little bit zero. That will have an influence when we define the general head boundary. So we have to do a quick, just a quick fix. Okay. What else is, and the trench will be located on the second layer. So this is the initial condition. Okay, and the K, we are talking about cents. So this is 7 10 to the minus 4. The first three layers are convertible. Well, the first two layers can be convertible, and the third, from the third, will be confined. Okay, and the anisotropy will be 2. Great, great, great. You are doing fine, amazing. Okay, so yeah, this model won't have any recharge transpiration, because actually the impact of the recharge rate and the evapotranspiration over something that develops on the CC actually will be minimal. We guess so, so that's why we don't consider. Okay, we define the intersection option. We are not going to uh, we are not going to use this one. Mhm. Or not in that way. Okay, so not in this, as this. Okay, so we insert many cells below. Okay, great. So now what we are going to do is the regional flow. We are going to read it. We are going to okay, so instead of setting up for 0, okay, intersecting the shapefile to the elevation of 0, okay, because that should be the elevation. Okay, we set to -1, trying to get the first layer. Okay, so this is a trick in order to get the first layer, because on the dam there are elevations that are slightly lower than 0. So, and this will be the general head boundary condition. And now let's work with the drain package. Okay, this drain package, okay, it's very interesting, the way that we are going to work here, because to work with the drain excavation or to do some massive tunnel modeling on the regional scale, okay, is really simple. Okay, because we have to loop over the different we have to loop over the different files. Okay, we have to no over the different not files, sorry, over the different rows, 1 2 3 4. Okay, so and this starts from 1. Okay, okay, so and for the first stress period, actually no the first stress period has no drain because there is no trench. Okay, and the second stress period, okay, the second stress period over the, because now this is Okay, this is looping over every row. Okay, so it's getting the cells of that row. That means that stress period. Yeah, so this will be the and uh, we append for that the elevation is minus 4.5 and the conductance is 0.01. Okay, so we got this. Okay, and then here we can plot the this. Okay, if you see here that that's actually not that big. Okay, but it doesn't look big because uh, due to the refinement is really thin. Okay, but here is the trench for stress period 2 and for stress period 3. Okay, that's it. And here we can show on the cross section at the intersection of the cross section with the drain. Mm -hmm. Mm -hmm. Mm -hmm. What had happened here? Ah, okay, the K pair 3. Okay, so this is the intersection of the cross section with the drain. So here we see for that stress period. Okay. Uh, well, actually, this is not used as well. Okay, so now this is the output record and then run the simulation. Okay, now it's running for stress period steady and the four transients. Okay, so we can plot the stress period 3. Okay, so here we see the okay, so here we see the for example the this is 3 2 1. Okay, so here we see the train excavation for this day. Okay, then it will come stress period 4 will come this and the stress period 2 will the drawdown will be here and so. Okay, so and we can do a cross section for the stress period 3 and we don't have head 2. Okay, so here we see the cross section and the drawdown as well. To this stress period and as well. Okay, some post-processing, we generate an array, we export the water table, and then the water table we uh, generate as a control. Okay, finally, okay, because this tutorial is on introductory level, so actually you are not okay, you are not required to, okay, we are not going to go so deep into the model, so we are going to generate the okay, so 3D generation, this is on model files. The executable is not necessary, but it's like this. So we open where we are going to store on the VTK folder. We list the model, we open the model. Okay, we have the geometry, the parameters, And the boundary conditions, we are going to run this for 0, okay, and because as well for 1. Why for 1? Because the uh, the drains are only for the second stress period, okay, so that is why we generate this. And the heads will be for 1, and the water table will be for 1. Okay, let's open ParaView. Okay, here you can open the water table. You don't see that because there is a, no, you can open the water table. Okay, these are the water table, and as well the raster file. This is the raster. Okay, great. So in here you can open the trench excavation, the VTK. We can open the water table. Okay, so this is the water table. And as well, we can open the, okay, so what I see, the drain. So this is the drain, as you see here. And then we can open as well the general head boundary. Okay. And here you can see the impact of the drainage. Okay, so that will be the tutorial for today. Just remember that all the files are in the description of the video, and to show to remember that we are a knowledge platform for, or a platform for knowledge sharing. We have a lot of courses and diplomas that you can take, great, and in this website and in this website, no, in this website as well. Okay, we are going to do a comparison of all the, and of all the, or we are going a compilation of all the tutorials ever done in mf6Voronoi in one link, because this link will be the main source to learn mf6Voronoi for your own. Okay, so wait for that. And if you want to support us and support our if you want to support our research, we strongly recommend that you follow us in Patreon. Okay, so that will be everything from my side. Have a great day. Bye.